what we have done in the last class, that's we have done the quick introduction session in the last class, if you guys remember that, if somebody's there. So we have discussed like how we are gonna proceed the service provider training, right? So we are gonna basically gonna start from the CCNA level to the CCNA level of the CCI training, right? So even if you don't have any knowledge about the service provider, you will get the understanding about the service provider, how the service provider is there, what is service provider, whatever the devices we have in the service provider, what technologies we have in the service provider. All these things you are going to learn it over here. So let me quickly recap what we are going to do that, right? So we are going to start from the routing part. In the routing, we are going to first see that how you can, whatever the types of router we have in the service provider. Then we'll see the routing protocols, like a static routing, and we'll go with the dynamic routing as well. In a dynamic routing, we'll discuss about the OSPF routing protocol and ISS routing protocol. Once we have done with this two part, then we'll go with the BGP protocol, right? So we don't have a EHGRP in the dynamic routing, in a service provider, right? Because normally in the service provider network, we don't run the EHGRP protocol. We majorly focus on the link state routing protocol, which is the OSPF and ISS. Once we have done this part, then we'll jump to the VPN. In the VPN, we are going to talk about the L2 VPN, right? And the L2 VPN, we're going to talk about the XConnect, the BPWS, BPLS, the BGP EVPN, VPLS, L2 EVPN, right? So we are going to discuss the L2 EVPN over there. And then once we have done with the L2 VPN, then we'll move to the L3 VPN. In the L3 VPN, we have a MPLS, right? At the same time, once we have done with the MPLS, then we have a option A, B, C, right? That's we are going to discuss in the L3 VPN. And once we have done with the L3 VPN, then we are finally with the multicasting, right? How you can deploy the multicasting like the IGMP protocol and the PIM protocol, and how we can introduce the MVPN, right? Before we are going to move to the MVPN, we'll also see the behavior of the GRE. Once we have done with the multicasting, we'll move to the quality of service, the pipe model, and the sort model as well. And once we have done with this part, then we'll go to the traffic engineering, the RSVP protocol, right? Once we have done this part, then we'll go to the segment routing, SR, right? After completing this part, right, then we'll do the same configuration on the IPv6 as well, because this configuration, the static, dynamic, all those things we have done in the IPv4, then same thing we are going to do on the IPv6 as well, right? After completing this part, the IPv6, then you have a automation, the final and last one, right? Once we have done this part automation, right, it's not a last, I forget, sorry, that we have a infrastructure as well. So how we can improve the security in the service provider network. That's part of the infrastructure. So this is the final agenda of the SP training, right? Again, all this technology that we are going to talk about, the static dynamic routing protocols, L2 VPN, L3 VPN, multicast QST, segment routing, right? Everything we are going to discuss according to the perspective of the iOS, right? XC and XR, because this is the service provider we have, right? Normally, the types of operating system, if I talk about, we have iOS, we have a Catalyst, we have a XC, we have XR, we have a Nexus operating system, right? So we are going to do all the lab. Let's take example. If the static route, if I'm going to start it. So how are we going to do the static route configuration? We are going to do the static route configuration on the iOS router. We are going to do the static route configuration on the XC router, and we'll do the static route configuration on the XR as well, right? That's called as a service provider, right? I can teach you all these things on the iOS router. That's perfectly fine. But the problem is that when you go to the service provider network, and normally in the service provider network, what happened? You majorly 90% chances you're going to encounter the XR devices. XR means what? This is the operating system we have. You're going to encounter the ASR router, right? ASR 9000, right? You're going to get the NCS as well. Or finally, the new of the router of the Cisco, that's called the 8000 Spitfire router. These are the basically router that you're going to encounter in the service provider network, right? You may encounter the XC as well at some point, right? Rarely you will get the iOS one. Really, in the sense of what? Let's take example, you have a small service provider. They do not have a much load on the router side. Then you can get the iOS one. But majorly, if I talk about, you will always get the XR, the ASR 9K, NCS, and the 8000. And we'll do the configuration, right? We'll learn all this L2, L3 VPN multicasting according to the XR perspective and the XE and IS perspective, right? Anyone has a doubt over here, guys? Anyone who has a question regarding the any technologies who want to add something over here more?
Can I have one question?
Go ahead, I'm Hemant.
Yeah, for SR, are we going to configure for the SR-v6 as well?
Yeah, SR, we are going to configure the SR IPv4, then SR v6, and the final the coloring as well. That's a traffic engineering.
Okay, SR-v6, everything like
Right.
BGP, ISS, everything configuration, right?
Of course.
Okay, got it. Thank you.
In the L2 VPN, we are going to start from the very basic, like a Q&Q tunneling, right? And once we are done with the Q&Q tunneling, and we'll see that what is the problem of the Q&Q. Once we understand the Q&Q problem, then we'll move to the VPWS. That's a point-to-point. X-Connect, you can call it in the normal language. Once we are done with the X-Connect, then we will jump to the VPLS. Once we are done with the VPLS, then we'll jump to the BGP eVPN, right? Why we are learning the eVPN? What's the problem we have with the VPLS? And also, at not last, we have a 𝐓𝐕𝐞𝐬𝐧 as well. Because I have encountered the sometime what happened in the service provider network, you have a 𝐓𝐕𝐞𝐬𝐧 as well. Once we have done this part, right, on every technology like OSPF and ISS protocol and BGP, every technology will discuss according to the corporate example. Like what scenario you will get that in the production. What happened in the service provider network? What is the major role of the service provider network? What technology they are using it? What commands are necessary on that P router and the P router as well. So design perspective, at the end of this training, you will have a clear understanding of the service provider network, of all the commands. You will have a clear understanding of what commands are necessary on that P router and what commands are necessary on the P router as well. Okay.
Okay, got it. Thank you.
Most welcome. So let's quickly start with the very basic, right? How, like, as I mentioned,
sorry, sir.
Go ahead, Oscar.
Yes, I'm just viewing the lab outline details, and it's mentioned that for number 1, we are going to start with service provider architecture and evolution. Is this what we are doing today?
Yeah. So we are gonna start from the routing part, the how we can configure the IP address on the XR part, XR router, because normally how you can configure the iOS one is a very basic that you have already learned in the CCNP. So we'll understand how you can configure the IP addressing on the XR and what is the difference between the XR and iOS part.
Okay, but in terms of architecture.
Yeah, we'll discuss the architecture as well.
Okay.
Excuse me.
Yep, go ahead.
Sorry, actually I just joined. Just confirm me, like, because in MPLS this multicast, QoS and traffic engineering, right?
Yeah.
So regarding this, like, we will go in detail of these topics with configurations, or like how we will go?
Of course, man. We'll have a detailed discussion of the multicasting, right? And QoS. So in the multicasting, we start with the IGMP, right? First of all, then we have done with IGMP, then we have a PIM. In the PIM, we will discuss the dense mode. We understand the problem in the dense mode. Nobody will teach you the dense mode because people hate this guy. Right?
Exactly. But how we will do it? Like, you will configure, like you will create a scenario, and then we will do the configuration. It will work like
we'll
this.
do the theory, then we'll do the lab of this one, and then I'll show you the verification and the troubleshoot as well.
No, thank you. Thank you.
Okay. Any question has? Nope. Okay, let's move it. So let's quickly see that. Let's say example, you have a normal iOS router, normal iOS, right? I'll just take example of the normal iOS router. This is the normal iOS router we have. And another one, we have a XR router, right? Understand this case because the difference we have over here. Okay, first quickly ask the question to everybody, right? Have anyone worked with the XR router previously? Anyone has idea? Raise your hand if anyone has worked with the XR, ASR 9000 or NCS or the 8000. No one? Okay, great. Okay, so this is the router 1 we have, and this is the router number 2 we have. Let's say example, this is the XR router we have. Normally, if you see that, let's take example, let's give the IP address for the iOS router. I'll give this guy as a 0/0, right? I'll give this guy as a 0/0/0/0/0, right? I'll explain you this format, the 0/0/0. Don't worry about that. Okay. On the router number 1, if I talk about how you can configure the IP address, you just need to go in the, first of all, config mode. Under the config mode, you need to go in the interface 0/0 and say that IP address, that's a IP keyword. The first of all, this first command is going to represent that, hey, you are doing the configuration for the IPv4. And then I need to say that address for this one. And I can allocate the address for this guy as a 10.1.12.1. And then I can give this subnet mask information and no shutdown. That's all, right? This is how you can configure the IP address on the router 1. Let me tell you that once you did this configuration, what happened? Once you did this configuration on the router number 1, this configuration will be automatically part of the running configuration. It means that if you put the command show IP interface brief, you can see that on this particular interface, we have IP. You can see that on this particular interface, you have an IP address configured. This call as a single stage configuration. Why I call this guy a single stage configuration? Because once I put this IP address on the router interface, automatically what happened? This interface configuration will be there in the show IP interface table. You will see that 0/0. I have a 10.1.12.1. The state is up. Do I need to save this configuration to see that? No. I don't need to save this configuration. This configuration is a part of the running configuration right now. Okay, if you want to save this configuration, you can put the WR command, or you can say the copy running config to the startup config. This is how you are doing that. But if I talk about the XR one, right? XR, when I talk about the XR, you understand that I'm talking about the NCS perspective, right? The ASR 9000 and the 8000 as well. Because XR is the operating system and these are the boxes we have, the hardware. On the XR, what happened? When you go to the router number 2, right, and say the interface 0/0/0/0, the first command again, as the IP is going to represent that's IPv4, then we will say the address. And now I'm going to give that to 10.1.12.1, sorry. And I can define the IP address for this guy as this format. I can define in this format as well the concise way to represent the subnet mask information called as the CIDR. And I can define this guy as this format as well in the IPv4 command line. Whatever you want, you can go with. Why I'm telling you this part? Because when you move to the production, right, when you encounter the service provider network routers, sometimes what happens, people are used to configure who are the experienced, who knows the things in or out. They do the configuration like this way. And sometimes what happens, they do the configuration like this way. And people get confused over there. So don't confuse. Eventually what happened, any of the command you put it, the interface will take the IP address. Now what? Will it work now? Once I put the no shutdown command over there, by default L3 interface are down.
We need to save it.
Sorry?
We need to save it.
You need to save it, right?
Yeah.
How we can save this configuration on the XR?
Configuration commit.
Configuration commit. Do you think this is gonna work?
No. Just commit. Yeah, commit.
Commit.
We just need to commit this guy, right?
Yeah.
Now the focus over there, guys, what I'm trying to explain you over here. Over here, do I need to save this configuration? No. When I put this configuration, automatically what happens, this configuration will be a part of the running configuration, and I can see this one in the show IP interface table. If I talk about this guy, right, I need to put the commit. If I'm not going to put the commit, then what happens if you put the show IP interface table, you will never see the configuration of this guy. I need to put the commit keyword, right? There is no WR command over here. There is no copy running config. You need to see the commit over there. And that's fine. Once I put the commit, then what happened? My configuration will be the same. This is called the dual stage configuration. The single stage and dual stage. If I talk about the 𝐓𝐤 as well, the 𝐓𝐤 devices, 𝐓𝐤 is same behave like a iOS as well. So in the 𝐓𝐤, what happened? Same thing you need to do that on the 𝐓𝐤 router as well. No need to commit. That's also called a single stage configuration. But in the case of XR, you need to do the commit, and that's called the dual stage configuration. Why is it the dual stage? Because in the first stage, what happened? You just need to put the command. That's called the stage 1. In the second stage, what happened? You need to put the commit. Once you put the commit, then what happened? Your interface has the IP address, and now you can see in the interface table as well. Is that clear? Anybody has a doubt over there?
Okay, at my side, yes.
So now let's say example, this MAC address of this guy is the A and the B. I know it's a very basic CCNA level stuff, but I want everyone on the same page for the next topic. When I'm going to ping from the router 1 to the router number 2, let's say example, this guy has IP address is 12.1 and this guy is a 12.2. When I'm going to ping from here to here, router 1 to the router number 2. When I say the ping is just a command. It's not a protocol. Let me tell you that. Most confusing thing. It's just a command. It's not a protocol. The protocol is ICMP for this one. I say the ping 12.2 right now. When I say the ping 12.2, what happened? The router 1 will check in the ARP table. Hey, do I know the entry of the B? If you see the ARP table for the router number 1 right now, they have a own entry 12.1. They have A over there. They don't have a B. So eventually, the first packet that you have created over there, where we have a source MAC will be A, destination MAC, I have no idea. The source IP is 12.1 and the destination IP is 12.2. This packet will go on the hold. This packet will go on the hold because I don't have a MAC address information. Eventually, this packet will be dropped, eventually, but not the immediately. In a background, what happened, the by default ARP protocol is enabled on the IPv4 network, not the IPv6. ARP is not there in the IPv6. In that case, what happened in the background, the router will generate the ARP request. So where we have a source MAC will be A and destination I have no idea. So I'll put the layer 2 address FFF 12 times. That's simply going to represent that's a layer 2 broadcast MAC address. Source MAC will be A, again destination MAC, I put the 000, I have no idea. 12.1, that's my IP address, and 12.2 because I'm pinging the 12.2. So this is my Ethernet header and this is my ARP header. Now I'm going to send the router 1 is going to send the packet to the ARP request packet. This is always a broadcast packet. When the router 2 will receive it, what router 2 will do that? It will add this entry in the ARP table. Say that, hey, let me add this. So 12.1, because this packet is coming from the 12.1. I need to add this entry. The MAC is A. For how long? The 4 hours. That's a ARP timeout. This entry is a dynamic entry. For the static entry, you don't have a timer. And now when the router number 2 will receive the ARP request packet, he will create the ARP reply packet. In the ARP reply, what happens is a pure unicast packet. The MAC address is B, the source distance of MAC is A. Because now I know and now the source MAC again B and distance MAC A, the source IP is 12.2 and distance IP is 12.1. So finally the router number 2 will give the reply packet to the router number 1. This is the pure unicast packet. How it's a unicast? The reason is that unicast because I know the 12.1 is associated with the MAC address A. When the router number 1 will receive this packet, what router 1 will do that? It will add this entry 12.2 is now associated with the B now. during this process, right? This process, what do you think that how much time it will take? 2 seconds, 3 seconds, 4 seconds, depend on the process of the router and the bandwidth. Normally, in the Cisco router, the timeout, if I talk about the ICMP timeout, is what? By default, it's a 2 second. So during this process, what happened? It will take the more than 2 seconds, and that's why this packet will be dropped eventually. And this drop is called as an encapsulation failed. The reason is called encapsulation failed because I cannot put the destination MAC B over there. I cannot encapsulate the packet. And then remaining the other 5 packets, because by default, you are sending the 5 packets in the router side on the Cisco router. If I talk about the unicast packet type and broadcast as well. By default, you are sending the 5 packets in the unicast and broadcast. So the 1 packet will be dropped. The next 4 packet, you will have a successful, because now I have an entry for the B, 12.1 and 12.2. Now the ICMP request comes to the router number 2, and router number 2 will give the ICMP reply to this guy. And this is how your normal pinging is working between the same broadcast domain. Remember one most important thing. If you don't have a ARP entry in your ARP table, you always generate the ARP request packet. If you don't have an entry in the ARP table, you always generate the ARP request packet.
This ARP request through ping, right?
Sorry?
This ARP request through ping command, right?
Yeah, ping command. Ping is a command that works on the ICMP protocol.
Yeah, thank you. Very well explained. Thank you.
Now, let's come to the point, guys. Let me show you this basic lab so that you will have a clear understanding. Then I'll move to the SP label. Why this is not working? Hold on. Yeah. So I'll take the one iOS router. That's a router number 1. And I have a XRV as well. That's not there. It should be there. 1 minute, guys. 1 minute, let me call to the guy. It's not there. Why?
When you have a minute, can you share the iOS versions you're using?
Yeah, I'll share with you. Don't worry about that. I'll give you everything. All good, man. So basic lab. This is the XRB. This is the icon of the XR router we have. This is the icon of the iOS one. All good. And let me turn on this guy. And this guy as well. So XR, this router is a little will take the high process, right? And it will take some time to on it. So just have little bit patience level for the XR. So if you have like a 60 GB of the RAM or 32 GB of the RAM of your laptop, you can do the lab of the XRB, right? You can do the 4 to 5 routers, you can take it. And if you have 32 GB RAM, you can take the,
Hello, sir. You are muted.
yeah, I'm muted. I know. Okay, I got it. Okay, man. So let me give the IP to this guy. 10.1.12.0/24, right? And Great, that's good. And let me take a route access now. Let's get into the switch. Hold on, guys. Looks like there's some problem. Node. Oh, maybe I took the iOS router. Let me stop this guy and let me fire off you. Okay, let me add the routers. VLS1. Wait. Okay, that's good. Now let me open the notepad so that you will get the notepad at the end of the class. And the basic lab number 1, you can call it configure IP address on the router, right? Router 1 we have, you need to go in the config mode and interface 0/0. I have IP address will be 10.112.1/24. No shutdown, that's perfectly fine. And on the XRV 0/0/0 IP address and 10.112.2/24. No shut. And then finally we have a commit. That's a basic way we can do that. This guy now. It will take some time. Hold on. Still in the login page right now. Yep. So the default username, right? You can get is you can define the username and as password as well. So I'm just defining for the admin right now, and admin is locked, so I can go with the Cisco and Cisco 1, Cisco 1 and Cisco 1. Great, all good. And let's see the other one as well. All good now. Cisco 1. Cisco 1. Cisco 1. All good now. Right. Okay, man. Come on. Would you like to push the continue button? Yes. And the other one as well. So the basic thing, what you can do that, if you see that, I'll give the host name for this guy. When I say the host name router number 1, have a look over there. When I put the host name router 1, immediately what happened, this configuration will take place, right? Immediately what happened, this configuration will take place. I don't need to save this configuration on the iOS router. But if you see the XR one, if you go to the XR router, and if you just define the host name for this guy, let's take example, host name will be R2. One that looks like a this has got a stuck. This XR image. Don't worry, I'll take another RDP. I have it. So XR is a little bit high image, right? So it takes some time. And that's why people hate this guy. But I'm telling you, this is the imaging routers we have. Hey guys, just give me 1 minute. Let me take another RDP because looks like this has a problem. I have a good RDP. Remote desktop and okay. So come on, man. Yep. So give me 1 minute. Let me stop this lab and let's go. And I have it on the service provider, it's static route. And on this one, let me add the new lab, the basic IP address. Okay. And here we go. iOS. And that's good. And I have XRB as well. So two images are there, guys. Please pay attention. One is a XRB and one is the XRB 9000. Please try to install the XRB in your laptop if you are planning to do that. Don't do the XRB. XRB 9000 has a very high level of the images. It will require the more RAM of your laptop. It means that, let's say example, if you have a 32 GB of the RAM, you can only run the 1 to 2 XRB router maximum, and it will take the 20 minutes to of this guy, right? XRB is a very light image, so it will not take so much time. So I have this one and this one. Let's connect this guy. And now I can give the IP address to this guy 10.112.0 last 24. Let me change to this guy 20 and bold, and let's go it. Right. And let me start this person and start this guy as well. Hold on. Okay. Router number 1 and XRB. Wait. All good. So service came up. Meantime, I'll just show you that whatever the routers we have in the service provider, man. So go to the ASR 9000, right? Let's take example of 9010 router, right? So these are the basically routers we have in the service provider network, right? They have a, I'll explain what is the meaning of line cards and the route processor and the switch processor we have. But these are the giant routers that you see in the production network, the service provider network. So if anyone is working in the service provider, right, the big provider networks, so you can encounter this one. So this is just a one example that I'm saying that, but beyond that one, you will see the router. Let's say example, if I talk about this is the CRS router, one is the CRS router is there, right? And you will see this CRS router is like a, one rack, something like that. 3 racks will be there. So giant routers are present in the service provider network, but eventually the operating system, if I talk about, they have a XRV only. Frankly, I'll tell you, if you're gonna go with this image right now, man, it will take the one image, you can zoom it like a 6 to 8 GB of the RAM. That I can frankly telling you. iOS doesn't take it much time, right? iOS, if you have a 8 GB of the RAM of your laptop, you can run the 5 to 6 routers, 7 router, and 10 routers as well. But the service provider routers take much loaded. So now you can see that on the router number 1, say the node, the device is still not loaded.
Excuse me.
Yeah.
interview point of view, like we can explain in the same way, like what is the difference?
What is the difference with the XR and iOS and XRV? You're saying that? Hello? I missed you somewhere. Looks like there is a packet drop. Can you hear me? So host name on the router number 1, you can see that. I just gave the host name, and after giving the host name, what happened? You can see that the router 1 took the command, right? So there is no need to commit and there is no need to save this configuration, right? But on the XRV, let me give the host name Cisco 1, Cisco 1. So on the XRV, what happened? Let's say example, I give the host name router number 1. It won't take the configuration. It won't take the configuration in the case of XR router. What you have to do that, you need to commit this process. When I commit this guy, then what happened? Router 1 comes in the picture. And this is called as a second level of configuration, or you can call it a dual stage configuration. In the first stage configuration, what happened? You just need to put the configuration and that's perfectly fine. But in the second stage of configuration, what happened? You need to put the commit command and then it comes in the picture. Now, whenever you do the commit on the XRV router, whenever you do the commit of the XRV router, what happened? They will give the label for this one. Label is like what? A number, like a VLAN number 10, 20, 30 you have. Router has a router ID 1.1.1, 2.2.2. Same like that. Whatever the configuration that you're going to see by using the commit command, they will give you the label for that one. Just to identify who did this changes, right? Who did this changes? At the same time, what time this changes will be happen. So at the troubleshoot perspective, right? You can easily identify so configuration. If you see that commit change. So you can see that the configuration that I changed, host name router number 1. For this guy, when I put the commit, what happened? They took the one label for this guy. This label, you can manually change it as well. It's up to you. You can define the name as well for this label. By default, it will take the number, a random number. This done by the user Cisco. That's how I log in with this name and what timestamp they have done it. So this is a very good command. Based on this command, what happened? You can troubleshoot the network. So whenever customers say that, hey, some configuration has changed and due to that reason, what happened? I'm not able to access my router, or maybe my ISS flapped, or maybe my OSP flapped. So being a service part engineer, what the first step you will do that?
Hi, sorry, I got disconnected.
Yeah. Hi.
I asked one question, like interview point of view, if they will ask like what is the main difference between iOS and XR, the same way we can told them like we need to apply commit commands and these are the joint routers, or anything else we can tell them.
Theory perspective, I'll tell you that. Don't worry about that. I'll explain you that. Don't worry. Okay.
Okay.
So if you see that, this is the label ID for this guy, and this time this has changed. Now, if you want to see that what configuration this user has changed it, so you also have a command to see that. So configuration, commit change, and put the label ID for this one. If you're not able to copy this label ID, let's say example, like when you have a giant routers and multiples commits, they have done it. So you can simply say the last 1 or last 10, whatever you want. So by doing this thing, what happened? Let's say example, there is an X guy who did this changes on this router number 1, and then X has log out from their SIP, and the Y comes in the picture, and he would just want to see that what changes has done by the X. They can see it. Okay, this guy had changed the host name. So this is the very beautiful command. Based on this command, you can easily troubleshoot the network. Now, the second thing, what we can do that on the router number 1, interface 0/0/0. I'll give the IP address for this guy. IP address is what? 10.1.12.2/24. That's all. No shutdown. If you see one thing, I said the exit, do show IP interface brief. It won't show you the IP address configuration until unless I'm not going to save it. Once I save it, then what happened? Now the configuration takes place. Again, this is called as a dual stage configuration. Once I save this configuration, now you can see that. So configuration commit change. So configuration commit list. Now you can see that there's a two label is happening right now. So the first commit has done by this user at this time, and second commit has done by this user at this time. Okay, what configuration is present over there? So if you see that, so configuration commit change list, not list, last two, let's say example, I will get to know that what changes has done, right? What changes has done by this guy. So the changes has done the host name, router number 1, and on the interface label, we did this configuration. That's the best way you can troubleshoot the service provider network, what configuration has changes by the other engineers. Now, what basic things we can do that? Let's say example, I have a so IP route, you can see that. Okay, I haven't added it yet. Interface 0/0. No shut.
I have one question here.
Go ahead.
Like for example, right now you told like for example the shift of like now I'm in the night shift, for example, and I will do some configuration and I will commit it. But is it possible the guy who worked in the evening shift, he did some configuration but he didn't commit the configuration? So when I will commit the configuration, his configuration will also be saved?
Yeah, so that's a better way what you can do that. So
We can have, yes,
that.
so in the no,
So let's say
like
example, the guy has in the host name router number 2 right now, right? And after same time, what happened? You can get the loopback number 2. Let's say example, you get the loopback number 2.2.2.2 right now. Okay. In that case, you have no idea what configuration they did it, right?
yes.
And if I'm going to make the commit right now, then what happened? Both the configuration will be commit, right?
Yeah.
So what you can do that. So whenever you do the configuration, first of all, just make it clear. Now I've cleared it. Now if I'm going to make a loopback interface loopback number 1, IP address 2.2.2.2, commit this guy, and I can put this guy label as well. What? Okay, let's put the label. Label is what? The IP address is the loopback number 2, loopback number 1. Now you can see that the host name, the command I put it over there, it has not changed. But my loopback has been created. Is that clear now?
Even it will happen like for example both user will have the different username and password, even then like we have to face this
That's
situation.
perfect, no issue. You can, whenever you do the configuration, right, just make it clear.
Okay.
Now you can see that so configuration change. One interesting part over there, you can see that. So configuration commit list. So the user Cisco, normally the label ID will be the number. What I did that label ID, if you can see that, I put the loopback number 1. So whenever someone will verify the configuration, they can easily identify, okay, this guy has created the loopback number 1. So this is the best way to do the configuration on the service provider network, so that the other engineers can easily identify, okay, what configuration they have changed. Clear now?
So I have two questions.
Go ahead.
Yes, the first one is there any comment to show the uncommitted configuration before clearing?
Yeah, we have a so configuration. I'll explain, we'll have everything. Let's go with the basic by basic.
Okay. The second one and last
we are
one
only going to
is
discuss the XRV. Don't worry.
okay, just a quick one. The last, is there also a rollback command for this type
we
of
have
router?
you just put the so configuration.
Okay,
so if you put the so configuration command, so configuration will show you what configuration has configured but not yet saved. We have a command. No worry. I'll show you that. XR deep has a question. So XR also give a prompt that there is a ongoing commit session is the active and you still want to commit all the configuration. Yeah, basically what's happening on a ongoing commit, you cannot do that. You have to commit the complete configuration. So there is no option for that one. If you see that right now, it's not there. Maybe in future they will come. But when you put the, let's say example, you look back number 3 and answer the commit, I have only this option. So I cannot particularly select the some portion of the command and save it. I cannot do that.
I think my comment was more like for one of the questions where one user logs in and they have a commit and they didn't commit it, but again another user logs in and tries to commit. So XR gives us a prompt at that time, right? Saying that there is already an existing commit section and you want to commit all the configs.
So you are saying that the one user has already put the configuration and they have not committed. And then you have some put some confusion, then you are committing right now, and then you are getting this error, right? You're saying that?
It's not an error, but it gives a prompt saying that, hey, there are some uncommitted changes before this. Do you still want to commit? So XR does give a prompt like that. So in a way, we will know that if there are like uncommitted changes before our session, so it'll be easier to track down and probably, as you mentioned, do a clear and then go ahead and paste the configurations.
The best way you can do the clear, because we have never idea like what configuration has done by the other engineers, right? So I'll tell you, even right now, it's like, shutdown movement is going on in every service provider network right now. And they have locked the configuration everywhere. You cannot do any configuration changes in the service provider network right now. Mostly the service provider we have, you cannot do any kind of configuration changes. So the best way, the best part, how you can do the configuration, just make it clear and then start configuration from the scratch. If you have no idea, if you have an idea what, like, let's say example, if you get the handover call, right, from the previous customer engineers to you, and they have explained you, I did this kind of configuration change, and you know this thing, then you can simply put the configuration commit. Okay.
So when you do declare only erase the uncommitted configuration.
Yeah,
right?
Ongoing configuration only, right? Exactly. Not
Okay.
the committed one.
Okay, because like how it is in maybe in some firewall like ASA, if you clear config, or all the running config will wipe out.
Man, personally, I'll tell you, I don't like a security. Let's come to the point, guys. So let's have a debug ARP, and I'll show you how the ARP is working finally. So if I'm gonna ping pong from the router 1 to the router number 2, and you can see that I don't have ARP entry. My ARP entry is empty. My only have own ARP entry, that's to a lot 1, and that's my MAC address. Let me have copy this one, and I'll paste it over here as well. And I think so. This guy has a 2. Let me check it. What's MAC address of XRV? Show interface 0/0. Okay, man. What's your MAC address? Okay, same 002 and 001. So I'll just change it over here right now. All good. So now let's ping pong from the router 1, and I'll go. That's fine. Let's enable the debug over here only, and 10.1 to allow 2. When I ping it, if you see that, what's happened? By default, I'm sending the 5 packets in the unicast and broadcast as well. Multicast do send the 1 packet. The size of this packet is 100 byte, and the echoes to I'm sending to the 2 and the timeout is 2 seconds by default. Timeout means what? If I'm sending the request packet, I should get the reply packet within 2 seconds. If I'm not getting it, I will drop it. I'm creating the ARP incomplete entry. So there is a 2 types of entry. One is called as a complete entry, and one is called as an incomplete entry. This incomplete entry is only valid for the 60 seconds. It means that if I send the request packet, right, ARP request packet to the router number 2, background what router 1 will do that, it will create the incomplete entry for the 2. And there will be no MAC address because I'm waiting for the reply. Once I get the reply, then I'll put the MAC address B over there. So once I will get the reply, this entry is called as a complete entry. If I'm not getting the reply, this entry is called as an incomplete entry. This entry will automatically vanish after the 60 seconds. So now you can see that I'm sending the request packet to 1 from this MAC address to which guy? this guy, I'm putting the distance max 000 because I have no idea. I'm sending this packet to the 0/0. Once the router 2 will receive it, it will give the reply packet to me by using the own MAC address. So R2 is putting the own MAC address in the reply to the router number 1. And now once I receive it, my first packet get dropped and the remaining all packets are successful. So now you can see the I have an entry for this one. How long ago I learned this entry? It's a 1 minute ago. This entry is only valid. This entry is only valid for the 4 hours. That's called as a ARP timeout. Now let's take example. If I'm pinging to the other guy, 10.1.12.3. Do we have this IP address in this network? Tell me. Do we have this IP address? No, right?
No.
So what happened? I'm gonna send the request packet, request packet, request packet, request packet, and request packet. Getting the ARP incomplete entry, sending the request. This entry will be there in the routing ARP table. For how long? Just a 60 seconds. And after some time, what happened? This entry will be vanished. All good, guys? This basic part is clear?
Yeah, that's okay.
Okay. Now let's come to the XRB as well. If you even the XRB right now, you can see that the default ARP time is the 4 hours. Okay, why I'm showing you this part? Because depend on the iOS by iOS, right? Operating system by operating system of Cisco, the timers are vary, right? These timers are very important because if the timers are mismatched, it will create the unknown unicast flooding in your network as well, right? So Nexus data center devices have a different time. XR has a different one, iOS has a different one. But the service part, if you can see that iOS and XR both have the same timeout. But if you go to the Nexus operating system, they have a 1500 second for the ARP timeout. All good. So even see on the XRB show ARP, I have a entry and I learn this entry via the dynamic way. Dynamic is what I learned this entry. And this is the static entry for the 12.2. And for the static entry, there is no timer. So this is a permanent infinity. Right? Now, I hope the basic part is clear to everybody right now. What I can do that, let me stop this lab. I'll introduce the static route lab now. It's not this one, not this one. Yeah. So simple one. Have a look over there. Let me, before I'm going to explain you this static route, let me explain you the routing first of all. Can anyone tell me what is, okay, hold on. I need to open a new paint file. Can anyone tell me why do we need op routing? If you already have a layer 2 network.
No, you need routing to be able to reach network that are not directly connected.
That are not directly connected, right? But why do we need op routing if you have a layer 2? That's my basic question. Like you have a layer 2 network, right? Such as PC. Why do we need op routing?
Segmentation.
To connect different networks, right?
Why do we need a different network?
Security.
No, actually the question is like if we are having the layer 2 network, so routing is
I
required
have
or
a layer
not?
2 network. I have a 10,000 PCs connected.
No, layer 2 network, you cannot go, the broadcast domain is within the same, but you cannot go beyond the router to another network. So you need routing to be able to reach
I don't want this guy right now. I don't this culprit right now. Leave it. Forget this guy. Let's go to the 90s, 80s.
Okay.
Okay. I don't have a router switches, I have only. Why do we need up? If you already have a layer 2 network, what is the requirement to go to the layer 3 now? Why should I introduce this router?
Yeah, because if you don't have a layer 3 device, the broadcast domain will be too large. You know, that way feel.
So one guy has said the segmentation and the security, right?
Yes.
So let's take example. In the layer 2 network, what happened? If the PC number 1 is gonna send the ARP request packet, that's a broadcast packet. It will be listened by all the 9,999 users.
Yes.
Think it, imagine it. If you have a big service provider network and all they are the layer 2, what happened? All these guys flooding will be happening in the network. The wastage of bandwidth, wastage of CPU cycle. And there will be no security. Anyone can perform the attack, DDoS attack in your network. The 𝐓𝐤𝐦𝐞 user who can perform the DDoS attack in your network. Let's say example, there's a DHCP server, and this is the part of the same VLAN as well, same broadcast domain. This 𝐓𝐤𝐦𝐞 server, if they want to destroy your network, they can destroy this DHCP server. And if the DHCP will be destroyed, all the user gone. They cannot even access the internet. They can communicate within the LAN, that's fine because of the APIPA. But WAN communication will be gone. So to improve the more security, right, and the segmentation, we need a layer 3. In a layer 3, what happened? We have a device that's called a router. That's called a router. Router is a device, right, that provides the routing. Every device interface of the router. Understand this, guys. Every interface of the router has a separate broadcast domain, right, and collision domain as well. It means that if you have a gig 0/1 interface, you have this network. On a 0/1 interface, you cannot give the same network. Never, you cannot give it. You have to go with the different subnet. That's the meaning of every interface has a separate broadcast domain and separate collision domain as well. In a router, right, router maintains the routing table, right? Router maintains the routing table, but by default, the routing tables are empty. You don't have anything over there. How does this router create the routing table?
Yeah, but law, like you said, if you have the same different VRF, you can have the same IP address on two different.
Yeah, definitely, man.
I was just gonna say that.
Looks like everyone is hunger with the VRF right now. Okay, let's come to the point of the router number 1, man. So on the router number 1, if you see that, I open the same 𝐓𝐷. Let me open this guy, router number 1 right now, this guy. If you see the router number 5, I'll show you how does router will create the routing table, first of all. Then I'll come to the routing part. By default, router doesn't have anything, nothing, empty, everything. Right, you can see that. So IP root, nothing we have it. Class memo, I'll call you sometime. Nothing we have it. Then how does it create the routing table? So put the command debug IP routing. Beautiful command. I'm telling you, debug is an amazing way to learn, but don't do that in the production. And I see the interface loopback number. Let's say example, IP address will be 101.1. Let's 555. When I put this command, what happened in the background, you can see that I added this route in my routing table. I just put the loopback IP address, and background what happened, I enable the debug IP routing. Right, they add this route. 0.0 means what? It's a locally connected route. Directly connected, you can call it. And for the directly connected route, the AD is a 0 and matrix is a 0 on the Cisco router. When I delete this guy, now you can see that do show IP route. I have a routing table. When I'm going to delete this loopback, no loopback interface, loopback number 5. I think so, no interface, loopback number 1. What happened? The router will delete this route from the routing table. Now it's gone. So remember one thing always, it's very, very important. I'm telling you guys. The route only you see in the routing table, right? When you have that IP address configuration on the router side. If you don't have IP address configured on the router, you will not have a routes in the routing table. So router maintains the routing table, and based on the routing table, router forward the packet. But routing table always maintain the connected route by default. Connected route means what? The route that is present on the router side, and you have manually defined the IP address on the router side. So on the router 1, if I say the interface loopback number 1, IP address will be 101.1/8. Interface loopback number 2, IP address will be 2.2.2.2.2/8. So only this route will be there in my routing table 1.0.0, loopback number 1, C 2.0.0, loopback number 2. C means connected route. Only this will be there in the routing table, nothing else. If I delete this loopback, it's gone. So let's give the basic IP configuration on this router right now. Or let me check first of all, do I have a configuration saved or not? If I have it, then I need to watch the configuration.
Hi, so I get another job.
Go ahead. Do you have any question?
Sorry, I come up here by mistake. Apologies.
No issue. I need to stop this guy and I wipe this configuration all because I think the configuration is saved on this route. And meantime, what I can do that, I'll open the notepad. Okay, this is not for the, hold on. And I'll start the configuration for the router number 1. Lab number 1, configure IP address on router number 1. I have it, interface 0/0. 10.1.12.1/24, no shut. And router number 2, we have interface 0/0, 0/0. I have a 2.12.2/24, no shut. Commit this guy. And I'll show you the another commit way. Commit 2.2.2.2. And I'll give this guy as a label as well. Commit label, loopback number 1. Lab number 2, we have configure static router. Right? On router number 1, let me start this lab. And on the router number 1, that's my XRV router. So I'm going to start the configuration for the router number 1. I have a config terminal. Let's give the hosting for this guy. Interface 0/0/0. IP address will be 10.1.12.1/24. No shut. Interface loopback number 1, which is the IP address of the router number 1. That's good. Commit this guy. Right? Remember one thing. If you have a bulk configuration, put the one commit. If you have a bulk configuration, put the one commit. Don't do the commit. Because if you do the multiple commit, then what happened? Your router will have a multiple commit label. And that will become the hard to troubleshoot for the another engineer. On router 2 as well, I'll better to copy and paste this configuration. Right? So on router 2, we have a 12.2 this interface. And then I have a loopback. And I don't need to commit this guy right now. Interface 0/0/0/0/1. IP address will be 10.123.2/24. So anyways, you can give the IP address. So I'm giving this way right now. R3 we have. I need to change the host name for this guy. And R3 we have as well. R3, this guy will be this one, and this should be the 23.3. So this IP for the R3 will be 23.3, and the loopback will be 3.3.3.3, and this will be the 34.3. Okay. R4 we have now. And all good. This is the router 4 now. And the interface, we have a 34.4. The loopback, I have a 4.4.4.4. And then finally, we have this guy will be 45.4. That's good, right? R4 is also done. And then finally we have router 5. Router 5 is a normal iOS router, man. So this lab is all about the XR plus iOS. Interface loopback number 1, IP address will be 545. So no need to commit this guy. Fine. Great. So let's take a console of every router. Router 2 now. 3, 4, and 5. By default, router maintain the connected routes in the routing table. They don't have any other route. So Cisco is my username, Cisco 1 is password, Cisco 1 is password. Good. Cisco 1 is password. And let's give the copy and paste this configuration. So I will share this notepad file and you can use this one for the lab practice. Oh man, hold on. Config terminal. Right, and copy and paste it. All good. So the commit had changed and the router has a name. On R2 as well, Cisco is my username, Cisco 1 is password, Cisco 1 is password. Cisco is my username, Cisco 1 is password, and config terminal. That's good. R2. R3 now we have. Let me know if you guys have any doubt. Okay. Don't try to ask the question because everyone has a different level of mindset. So you can put the question if you have any doubt over here. Cisco 1. Even if you have any doubts regarding your production network issues, feel free to ping me. And all good. R3 is done now. R4 as well. Cisco and Cisco 1, Cisco 1. Cisco 1. We are good to go now. And there are 5 now. Finally, that's my iOS one. From the CCNA level, your CCNA, CCNP, and even the CCIE enterprise, right? You are keep learning the iOS only. Service provider, when it comes in the picture, you are learning the XR and XC and iOS as well. When you go to the data center level, you are understanding the only Nexus. But nowadays, the data center also has a XR configuration. I mean, say some data center has XR as well. Hostname router 5. All done. So the basic part, the basic configuration is done now, right? So what I told you that router maintains the routing table and they only have a directly connected route only. And for the directly connected route, the matrix is 0 and the AD is 0. So if you see, if you go to the topology, on the router number 1, if you see the routing table, right? Show IP route. I can see my only own route, the 12.0 and the loopback number 1, which is the 1.0. Right? C means 1.0/8 route, loopback number 1. The one route you can see that 1.1/32 is the local route. Right? Same thing 12.0 we have /24, and for this guy we have a local route is the 12.1/32. So this local keyword, it was not there in the older iOS version. It was introduced in the new one. So every router maintain the local routes for that particular interface. So if any packets come to the 12.1, so I don't need to delay this packet. I will directly forward the packet to this interface. Longest prefix match rule that you can call it. But I don't have a route for the 4.loopback right now. I don't have a route for the 5.loopback. So if I'm going to ping, let's take example. If I'm going to ping to the 5.5.5, normally what a router will do that? It will check the routing table. Hey, do I know about this guy? The router say that, hey, I don't have an idea of this guy. So if you don't have an idea of this guy, then router will simply drop the packet. That's how we do that as well. Let's say example, if you're going to make a phone call to me, and if you don't have a number, then what you will do that? You cannot make a call. Same thing is happening with the router as well. Router say that, hey, if I need to send the packet to the any network, 8.0, 7.0, 5.0, I need to know the route for that guy. If I don't know, I cannot send the packet. So there is a two ways, right? There is two ways to bring this route in my routing table, right? There is a two ways to bring this route in my routing table. Come on. Which route? The 4.0 and 5.0 as well. What we can do that, either you can follow the static route, or either you can go with the dynamic one. A static is saying that, hey, it's a manual configuration. Manual means what? It's a box-to-box configuration. So you need to go to the every box, router number 1, 2, 3, 4, 5, and configure the route. So let's say example, which route router 1 doesn't have it. Router 1 don't have the 23.0. Router 1 34.0 doesn't have it. They don't have this loopback. They don't have this route. They don't have this route. So manually on the router number 1, I need to log in it and configure these route. That's a manual process. You have to do that. Leave the pros and cons. We'll discuss the design perspective of the static after once we have done with the static route configuration. We'll discuss it. But this is how you have to configure it. That's the meaning of manual configuration of the static route. Same thing on the router number 2. What we have to do that? Which route you don't have it? On router 2, I don't have this loopback. I don't have this route, and I don't have this route, don't have this route, and don't have this route. Same thing when I go to the router number 3 right now. Which route I don't have it? I only have a 23 and 34. This is my directly connected route. I don't have this guy. I don't have this guy. I don't have this loopback. I don't have this guy and don't have this guy as well. So simple way, static route means what? The route that you don't have in your routing table needs to define it. The route that you don't have routing table, you need to define it. So on the router 4, you can see that I have a loopback that is my connected. I have 34 and I have 45. But do I have a 5.0? No, I don't have it. I need to define it. Do I have a 4 to 23 and 12.0? No, I need to define it. Now let's say example on a router 4. I don't want to send the traffic to the 1.0.0 loopback. For example, I'm just telling you, I don't want to send the traffic to the 1.0 loopback. I will not define it. If you have a requirement, define it. If you don't have a requirement, don't define it. But let's say example, if the router 4 doesn't have the route towards the 1.0.0 network, then this guy, router 5, when this guy is going to send the traffic to this guy, they cannot ping it, because when this router will forward the packet to the router 4, router 4 says that, hey, I don't have a route for the 1.0. So in the manual configuration, static route, every router must have a complete information. All good? How we do the define the static route on the normal iOS router? How many ways we can define the static route? Anyone tell me? How many ways we have defined the static route? Hmm?
You mean
IP route?
ways? You just do
Yeah,
IP
how many
route?
ways we have?
One way I know. I don't know of other ways.
Yeah, Godwin. Anyone else?
Route map?
Come on, man. Looks like you're moving to forward right now for the policy part.
2 ways, next hop or interface name.
Interface and next hop. Anyone else? Third one. So we have 3 ways to define the static route. Right. The first way is what? You can put the command IP dot. This is the first command will tell you the IP means what? IPv4. Route means what? Which route I'm looking for right now. Then destination network. This is the syntax that I'm telling you for the iOS one. I'll come to the XR. Don't worry about that. Submit mask. And the next hop. The second way is that we have it. Submit mask. And then
No.
interface. The third one, the final one, recommendation one in the production. Okay. That's a third way we have. So let's go with the basic right now. This one. Then I'll come to the exit interface and next stop, exit plus next stop, and we'll see the difference. Don't worry about that. Let's go with the basic one, this one. So on the router 5, right? If I start with the configuration for the router 5, because iOS is a pretty simple. So let's go with the router 5. On router 5, which network I don't have it? I don't have this loopback. I don't have this network. I don't have this network. I don't have this network. And I don't have this loopback. So in the router 5, we need to define all this route. .45.4 IP route, I don't have it. 34.0 as well. Same next hop. 23.0 as well. Same next hop. Same next hop. And look back, finally, we have it. Same next hop. Next hop means what? Always remember that the next hop is just gonna tell you your neighbor IP address. Next hop is always your neighbor IP address. So for the router 5 perspective, my neighbor IP address is the 45.4. That will become the next hop IP address for me. That's the first way to define the static route. This one, the next hop one. On the iOS router. But if I tell you about the XR, man, this is the iOS configuration. If I tell you about the XR, in XR, what happened? There is no command for the IP route. How you define the command line on the XR? So on the XR, you just need to give the command router static.
Static, yeah.
And then you need to define the which version of the which version of the IP you are running right now. IPv4 and IPv6. So these are the family. For the family, which command we have it? Address family. IPv4, unicast. And then I can define, let's say example, I don't have it out for the 1.0. I'll give the submit mask information. And the next stop will be 12.2. That's committed. That's fine. So this is how you are going to define it, the command on the XR router. So IP route keyword is not there. Yeah, we do have all these 3 ways on the XR as well. We'll see that. Don't worry about that. But the normal syntax of the XR is this one. Have a look on the router number 1, XR. I'll go and say that router static, address family, IPv4 unicast. Which network I want to go? Let's say example, I want to go to the router from router 1 perspective. I want to go to the 23.0 network. So I turn on 23.0/24. And my next stop will be 12.2. For the router 1 perspective, here's my neighbor IP address. Cool. Next, what network I don't have it?
But can you use the 3 method on this your route you want to define, this route you want to define on SR road? The 3 method, maybe the second one, the second method, the third one, the third method.
Yeah.
To drive home the point.
45.0 now, /24. And the 4.0 loop back that I don't have it. Same next hop.
No, what I'm saying, Law,
Mhm.
the second one, maybe you use the second route you want to define, you point it to the interface. The third one, you put everything together so that we'll know the three of them.
You can do that as well.
Well, can you try it here as you are typing it?
I'll do that. I'll do that on any other router. Okay, don't worry. I'll show you that.
Okay.
Just to show you that, nothing else. But we'll see that detailed discussion later. Okay.
Okay.
Now I can put the commit this guy. So once I put the commit, right, then what happened? Router will have this configuration. You can see the configuration now. What? Either you can put the show running config. It will give you the bunch of configuration. Right? Simple way what I can do that. So running router static. It will show you what configuration we did it. The one explanation mark, it's gonna tell you the one exit. Another explanation mark, it will tell you another exit. Same configuration. Let's do that on the notepad. So we have router number 1. On router number 2 now. So let's copy it and paste it. On router 2, what routes we don't have it. On router 2, if you see that, check the routing table right now. Cisco 1, show IP route. I don't have the 1.0. I don't have the 34.0. I don't have the 45.0 and I don't have the loop back. So on the router number 2, this guy setting, they don't have this guy. Define it. So let me go to the notepad and copy and paste it. So on router 2, I don't have the, let's go with the 1.0. I have a 12.1 as an extra. Let's go with the 5.0. For the router number 2, if you see that for this direction, what happened? My neighbor IP address will be 23.3. For this direction, what happened? My neighbor IP address will be 12.1. So based on the direction, neighbor IP address will be changed. 23.3. For this guy, I don't need you, man. 34, I need it. Next up will be 23.3 and 45.0, 23.3. Let's go with this way as well. And now I can make the 4.0 as well. It's good or got me now? It's fine?
Yeah. I thought maybe you put the interface first before the desktop.
Yeah, right. So we need to put the interface first. Forget that. Sorry. And I have a 23.3. That's good. That 23.3 now we have 4.0 as well. So this is the good configuration for the router number 2. And we are good to put on the router 2. And let's go and configure this guy. And I'll give the commit, right? What? Commit label is a static route. So the third guy will come and see what configuration has changed. So they can easily say, okay, so configuration commit list will be what? So someone from this user had performed the static route. The third one that I have it, Cisco 1. On the router number 3, which route we are missing right now? (23.2). For the router 3, I don't have this loop back. For this guy, the next will be 23.2. Then I don't have a 12.0 as well. For this guy will be 23.2. I don't have a 5.0, so 34.4. Let's remove this guy now. 34.4. And 34.4 as well. That's good for the R3, right? R3 doesn't have this guy, and this guy. So the 5 route we don't have 1, 2, 3, 4, 5. Commit R4 now. For this guy, we have a 45.4. So on R4, which route you are missing right now? This one, this one, this one, and of course this one. Only the 4. So for the 1.0, I have a next hop will be 34.3. What do you think for this guy? 5.0, 45.5, and the 12.0, I don't know. 34.3 again. For the 45, I don't need it. I need the 23.0 as well. And I don't need a 4.0 now. Come on. Okay, commit this guy. On the router 5, that's finally router 5 we have. I think so. I configure it or not. I don't know. So router 5, we already done it. So let's configure this guy. Okay. And go. Come on. And that's good. Basic IP address configuration is done. Static route is done. Static route. The default AD for the static route is what? Administrative distance. It's an 8-bit number, right? That's just gonna tell you the trustworthiness of the router, right? So if the router number 1 will receive the 1.0/8 route with the AD 10, and if the router number 1 also receive the 1.0/8 route with the AD number 20, router 1 is always give the preference to the AD number 10. Lower AD is always preferred. AD is a local to the router. Remember one thing always. AD is a local to the router, so you will never see the AD in the update packet. Never, ever. It's a local to the router. Depend on the vendor. Why vendor? ADs are different. Juniper, you will find the different AD. HP, you will find the different AD. Elsta, you will find the different AD. And Cisco, you will find the different AD. AD, the most important point, it's a local to the router, right? It's never exchanged in the update packet. Now, on router number 1, if you see that, the command, show IP route, I can see that I have a route. And for the AD for this guy's a 1.0, sorry, 1, the static route. 0 is the metric. Static route does not use the concept of the metric. Static route does not use the concept of the metric. And because of that reason, you cannot do the lots of policy with the static route. The only way to perform the path manipulation, right, in the static route is the AD. The only way that you have it. It doesn't have a metric concept. And that's why you always find the metric 0. He's saying that, hey, for this guy, the 12.2 is my next hop. So if any packets comes to me for this particular person, I will forward the packet to the router number 2. Same thing, even verify on the router 5. This is my iOS router. Do show IP route. I can see that I have this router as well. Now let's take example. Let's ping pong from the router number 1 to router number 5. This loop back to this loop back, end-to-end communication. Think about it. If I'm going to make a ping to the 55555, what happened in background? Right? Let's assume that the router 1 has a ARP entry for the 12.2. Assume it. We have it. So let's forget that right now. When this router 1 will create the packet for the 5.5.5 destination, router 1, right? If you don't define any source over there, it will take the by default the exit interface as a source IP address. So in the source, what happened? I will have a 12.1. If you don't define the source, by default the exit interface will become the source. But let's say example, if I want to change the source to the loopback number 1, right? I need to give the source keyword over there, loopback number 1, which is my 1 IP address. Now this packet comes to router number 1, right? This guy, router say that, hey, you know one thing, I have two types of forwarding. One is called the source-based forwarding, and one is called the destination-based forwarding. So two types of forwarding, router can do that. Whenever the router will receive the packet, it will check the source, and based on the source, he can forward the packet. That's called the source-based forwarding. Simple language, I can call you the policy-based routing. Traffic engineering, that comes in the source-based routing. But if you don't implement this feature, the source like a PBR and the traffic engineering, then it will do the destination-based routing, which is the default behavior as well. So every time whenever the router receives the packet, they will perform the destination lookup. And because of that reason, we call this guy the destination-based routing. Have a look over there. I need to forward the packet to the 5.5.5. According to my routing table, I do have this information. I need to forward the packet to the 12.2. Okay, that's perfectly fine. I need to forward the packet to the 12.2. This guy is very happy right now. But this guy got confused. Hey, which interface should I use it to forward the packet? I can have a 0/2 interface. I can have a 0/3 interface. Interface, you can call it as like a gate, a door. You are in the room. You have a bunch of door right now. Which door you want to exit it to go outside? So in the static dot, I haven't mentioned that. So the first lookup, right? The first lookup they have done. The first lookup they have done for what? Destination. Second lookup, that's I'm gonna done. For the exit interface. Now I need to identify which interface should I find it to go out. So in that case, what happened? When I find the 5.0.0/8, that's our first lookup destination 1. I need to identify which interface should I use. So I will perform the lookup for the 12.2 now. I will check where the 12.2 is connected. The 12.2 is connected via the which interface? The 12.2 is connected by the 0/0. So if you are sending the packet for this guy, I need to perform the 2 times lookup. The first lookup destination, second lookup exit interface. This mechanism is called as a recursive lookup. It's too cold in Delhi right now, so my hand is freezing. So ignore my spelling right now. Every time when the router will forward the packet to this guy, the router has to perform the 2 times of lookup because of the missing the interface over there. This mechanism is called as a recursive lookup, and this static route is called as a recursive static route. All good. Now you can see the packet now. Let's have a look. If the ping is working, then it means that our static route is good. Perfect. Same thing if you go from the router 5 right now and show IP. So IP route static, you can filter the routing table as well. Oh, one more thing. Remember one thing, router only by default, router only maintain the one routing table. Right? By default, router only maintain the one routing table. That's called the default routing table. You can call as a global routing table, except the management. Why I'm telling you this thing? It's a very, very important. I have seen that, right? Recently, I went on the call and the production issue was there, and the customer is a different level. So it's very, very important, because many of the person has a thinking about what router maintains the multiple routing table, like a okay, router has a separate routing table for the OSPF, router has a separate routing table for the BGP and ISS and static routing. It's not like that. You have only one routing table, that's called the default routing table, and the global routing table. I'm not talking about the management interface and management VRF right now. Forget it. What you are doing that you are just filtering the route. Let's say example, if I put the command show IP route, if you put the command show IP route, it will show you the complete routing table, like a OSPF, ISS, connected, everything. But if I just want to filter the route, I want to see the only static route, I will put the static keyword. I have a route for the 1.0.0. I can ping from here as well. Ping 1.1.1, source, loop back number 1. Again, he will do the recursive lookup, because you can see that for the 1.1.1, I don't have exit interface. So I will look for the 45.4. Hey, where is the 45.4 is connected? The 45.4 is connected by the which interface? The get 0/0. That's the second lookup I have to do that. And this calls as the recursive lookup. Ping is working. So if you see this show IP, I can show you in the Ceph table, the 1.1.1 detail. Can you see that? This recursive. So when you use this command line, right? When you use this command line to perform the static route, two important factor will be happen. The CPU and memory always comes in the picture. Not memory, CPU only comes in the picture. Your CPU will be always high. Sometimes you will get this kind of issues, right, in the production, like a CPU hogging on the router side. CPU is very high and you have no idea why it's high. And because of that reason, your other process is not working fine. So your one mistake, right? Your one mistake will lead the complete router into the problem. You say that, okay, I have configured the static route, my ping is working fine, right? But let me tell you, your ping is working fine. Being a network engineer, being a TAC engineer as well, we only look the ping pong, that's all. But when you go to the design level, architect level, you need to think according all the perspective. You're not going to think about the ping pong. You have to think about the, okay, what happens if I'm going to give this command line? If you're going to give this command line to achieve the static route behavior, recursive lookup will be happen. Let's say example, you are sending the 5 packets. How many lookup you are doing that? 10 times, 5 into 2. So CPU will be high. So let's say example, your router CPU is almost 100% right now is free. So your static route CPU will be consumed by the 80%. So do you think that other process will be done? The OSPF and the PTP and the NTP protocol? No. And even you can run it. Let's say example, your NTP is working fine, your PTP is working fine. Then you will see some delay over there. Sometimes you may see that the BFD protocol, the bidirectional forwarding detection, right? For the faster convergence. Sometimes you see the BFD flap is happening. Because your CPU is busy with some other process right now, they cannot process the BFD packets down. So to avoid the recursive lookup, what option we have it? We can use the exit interface. Is that clear, guys? Anybody has a question till this point? No? All good. So to avoid this problem, what we can do that? We can use the exit interface command line. So if you use the exit interface command line, you will not have a recursive lookup. So have a look over there. Let's take an example. Let me put this screenshot in the paint file. And I will go to the paint and I'll add it over here. Right? Now let's say example. I'll just give you the one route. For this example, I'll just change the behavior for the 1.0 as well, right? So I'll give the command over IP root. And I'll just change this behavior. 10.145.5. That's my next one. Okay, let's give the exit interface 0/0 and 10.145.5. So this is the exit interface that we have for the R5, right? Enter. 45.4, sorry. Now you can see the behavior. The difference is that if I put the same command, so IP sep table right now. Hold on. Do show on some static dot. It's gone now. Do you see the recursive keyboard now? It's not there. Now in that case, what happened? The second ways, the exit interface. This is the next hop one, right? And this is the exit interface one. What's happening over here? I don't have a recursive. If I don't have a recursive, I will not perform the recursive lookup. I can save the CPU. That's a perspective. Again, I'm repeating it. But this guy has a different level of problem. Let me tell you what's problem is happening. Let's come to all the router, and I'll remove the static route from every router right now. No router static. And Cisco 1. I'll remove the no router static. Commit this guy. R3 as well, Cisco 1. No router static. Commit this guy. R4 as well, Cisco 1. No router static. Commit this guy. And let's leave the router 5. I don't care about it because router 5 I've shown you how to configure it. And now let's configure the static route on the router number 1. We're using the exit interface. So I have this configuration. I'll copy and paste it. Copy and paste it. So on router 1, I have to use the no next hop, go with the 0/0/0. Copy. 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 I'm sorry. Yeah, 0/0 for the 1.0 and the 0/1 for the all this network. All good. R3 we have 23.2. This should be go with the 0/0/0. And this will be go with the 1. Okay. For the 2.0 as well, I have a 0/0. This is good now. And this is good. Let's go with the R4 now. On R4, we have this should be go with the 0/0. This will be 0/1. 0/0 and 0/1. 0/0, sorry. Let's change the R5 as well. Let's make a R5 Also the no static router everyone, and I'll change for the R5 as well. Okay. Let's do that this one as well. No. No, and I'll copy, and first I'll remove this guy on R5. Here we go. And now I need to configure E again. On R5, we need to remove the next hop and 0/0. /0. That's good, right? And I'll remove the no keyword. All good. Now on the R5, now we need to configure it. Here we go. The most important point now. Let me do something. Okay, sorry. Commit this guy. Commit this guy. Now I'll add this configuration on every router. Copy. Commit this guy. And on R2 as well. Commit this guy. R3 as well. Commit this guy and R4 as well. Commit it. So all the lab we will have it with the iOS and XR XE as well. I'll show you how to configure the static router on the XE tomorrow. And go ma'am to show IP route now. All good. Now interface 0/0 shut down and no shutdown. That's good. So if you go to the router number 1, right, and if you see that show IP route static, I have a route, right, for the all the route 5.0.0. Can I ping it? Anyone can tell me why I'm not able to ping it? Normal behavior. I do have a route. If you ping from router 5, right, to the router number 1, look back. The ping will work. Sorry, 1 minute. Yeah, the ping will also not work from here. But normally, if I go with the normal process of the iOS, right? Normal iOS 3 router with iOS, it should be fine. But in the XR case, it's not pinging. There's a reason behind it. The reason is what? Proxy. The proxy concept comes in the picture by default. If you do the same lab with the iOS router, no problem. Because on iOS router, by default, the proxy ARP is enabled. If you see that, so interface 0/0, right now, no problem on the iOS side. It's enabled. But if you come to the XR one, so interface 0/0, it's disabled. XR is disabled. The reason I'll tell you, XR are mostly used in the service provider network as a PE router, which is connected to the customer side. Customer can use the iOS, because they don't have much process on this side, but PE are connected with the multiple customer side. So they do disable the proxy R. By default, it's disabled and it's mandatory to disable it. Because this proxy R is creating the lots of problem in your network. If you're going to enable the proxy R, the first of all, what happened? You will get the DDoS attack in your network. So anyone can perform the DDoS attack in your service provider network. That's the first problem. Second problem is what happening. Anyone can send the traffic, right? This attacker can send the traffic to in your network. Because what proxy ARP is doing that? Proxy ARP is giving the reply of the R packet on the behalf of someone else. Right? Let's say example, let me give you the proxy ARP quick overview. So this is the PC1, this is router number 1, and this is the PC number 2 right now. They are the different broadcast domain. This is the IP address is 101.1. This IP address is 2.2.2.1. The IP address of this guy is a 1.100 interface, and this guy has a 2.100 interface. The MAC address is A, the MAC address is B, the X and Y. Normally, what happens when you ping from this PC to this PC? Right? What happened? The router number 1, right? When the reply request packet comes to the router number 1 for this guy, router 1 will give the reply on the behalf of this PC. So in the ARP entry on the PC side, you will get the MAC A. Because of the proxy behavior. So whatever the destination network we have in the service provider side, this attacker can send the traffic to this guy if the proxy is enabled. And because of this reason, because I don't want to perform the attack in my network, the service provider network, I don't want anyone can send the traffic in my internal network. What service provider side, what we have over there on the XR side, by default, the proxy R concept is disabled. And when you're going to use this command line, the exit interface.
But sorry, trainer, I don't seem to understand the way you explain this proxy app. Because when you want to ping another destination network, right?
Let me tell you that. Let me explain you over here. Hold on.
Okay.
Let's say example router 1 or router 2 we have, right?
Yes.
And I have a loopback number 2.2.2.
Yes.
Okay, that's a loopback number 1. And okay. I have a slide out, which is the 81.0 matrix. The next step is exit interface. I'm going to use it 0/0, right? I'm going to ping, right? So let's say example, the MAC address of this guy is A, the MAC address of this guy is B, right? And this is router number 1, this is router number 2 right now. And I'm going to ping from router number 1. 2.2.2.2, right? Router will create the ICMP request packet, right? In this ICMP request packet, the MAC address will be A. Destination I don't know. The source IP will be, of course, 12.1, let's say example. And the destination IP 2.2, right? This is the ICMP request packet will be there. Godwin, is it correct now?
Yeah, I'm getting you correct.
Okay, good. Now, what we have to do that? I will create the ARP request packet. In the ARP request packet, what happened? Now our source IP will be, source MAC will be A, destination MAC will be broadcast layer 2. Source MAC will be A, destination MAC will be 0.0.0.0.0. Source IP will be what? 12.1. Destination IP will be what? 2.2.2. ARP
Yes.
is a layer 2.5 protocol. Simply you can call as layer 2 protocol, right? When this packet comes to the router number 1, router number 2, tell me one thing. This is the one broadcast domain I have it. This is the another broadcast domain we have it, right? Can I forward this broadcast packet from one broadcast domain to the different broadcast domain? No, right?
No, by default, no.
By default, no. That's good. Now, what router 2 will do that in that case? They have two options. If proxy ARP is enabled,
No. But hold on.
Yeah.
Phil. When router A want to ping maybe 2.2.2, right? So the first thing it does, it checks the routing table to see, okay, where is 2.2.2? What's the routing?
2.2 is connected. I have a 0/0 interface. So I will forward the packet from the 0/0 interface, right?
Yeah, you say, okay, I have it on /0 interface, right? Okay, is it because next hop is not defined? Because it's supposed
Next
to.
hop is not defined because next hop is not defined, right? Exactly right.
Okay. Because next hop is not defined.
Next hop is not defined. That's why I'm making the ARP request for the 2.2.2.2.
Oh, I see.
Okay. So if the proxy ARP is enabled, right?
Yeah, if the proxy ARP is enabled and next hop is not defined, then there's a tendency that you can relay the app. That what you're saying, right?
No, that's something. Hold on, just give me 1 minute.
Okay.
So if the proxy ARP is enabled, then what happened? R2 0/0 interface will give the reply on the behalf of loopback number 1. So R2, right, this router, right, will give the reply. In the reply, what happened? The B is a MAC address, right? A is this guy. The source IP address will be source MAC B and A. The IP address will be 2.2.2.2.2 and destination will be 12.1. If the proxy ARP is enabled, then he will get the reply. Proxy ARP is same concept like your proxy guy in the classroom. Let's say example, I'm not there in the classroom, right? And the trainer is taking the attendance. And somehow the Godwin is there in the classroom. The Godwin is what? Job role is there. I already told to the Godwin, hey, Godwin, if the trainer will ask me, just put the attendance from my side. That's using a proxy. So when the subnet is not there in your broadcast domain, if the subnet is not there in your broadcast domain, which is the 2.2.2, in that case, what happened? The proxy guy will give the reply on the behalf of 2.2.2.2. If the proxy is disabled, right, then R2 simply drop the packet. They can't get the reply. So on the iOS side, by default, proxy ARP is enabled. XR side, disable. And because of this reason, you are not able to ping it.
Oh, okay. I get it now.
So now the point to be noted over here, if you're going to use the exit interface, the proxy ARP is necessary.
Ooh.
For this guy, no need. It's very important design level. I'm telling you guys, it's creating the lots of problem in the service provider network. I'm telling you, the service provider is not all about the configuration and the troubleshooting. It's all about the designing it, because once you've done the service provider training, you are good to go for the CCD exam. And have a look over there. The most important point. When you do the next hop over there, in that case, what happened? Router generate ARP request for next hop IP address.
Yes.
Okay. In this case, what happened? Destination IP address. Think about it. Let me give you the quick example. Router 1 and router 2 we have. 12.1, 12.2. the MAC address A and MAC address B. I have a 10 route, right, behind the router number 2. And for the 10 route, on router number 1, I have used the next hop configuration. And for the 10 route, extra 10 route I have. And for them, I'm going to use the exit interface. Do you know for the 10 route, you will have a single ARP entry. Single ARP entry because I'm generating the ARP request only for the next hop IP address. So for all the 10 dot 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, for all the 10 dot what happened? My next hop will be B only. So ARP request only will be B only for all the 10 route. But for the exit interface, what happened? You will have a individual entry for the MAC address. So if you're going to use this concept, in that case, what happened? You will have a higher ARP table. In this case, what happened? You will have a single ARP table. So if you see right now, let's go to the router number 1. If you see that, the first of all, to achieve the communication, what we have to do that we need to go on every interface, man. I need to enable the proxy ARP. First of all, never recommendation to do that. I'm just doing to show you that behavior. Commit this guy. Let's go to the router number 2.
So trader, that means if you define static route pointing to the interface, that means you have to enable proxy on all those interfaces.
Yeah, on the XR router, not the iOS side.
Yeah, on the SR routers.
Right.
Now by default on the iOS, it is enabled. The proxy app is enabled by default.
Yeah, on the iOS it's enabled. XC as well is enabled by default.
Okay, iOS and SC. Okay.
Yeah, but XR you need to manually configure it.
But if you ask me, why didn't they by design, disable route to interface on SRO since it will create problem?
1 minute, I'm coming to the point. I'll give you 1 minute. Come on. I'm not going to do anything on the XR iOS side because it's by default enabled on the iOS. Now I can ping bomb from here, man. It's going to ping. Ping 55555. Source loop back number 1. Have a look the most important and dangerous part of this command. Show ARP. I have an individual ARP entry for this guy. If I'm going to ping to the 4.4.4, I will generate another ARP request. Show ARP. Another entry for this guy. Can you see the MAC address same, which is the R2 MAC address of this interface. He's giving the reply. R2 is giving the reply on the behalf of 4 and 5. But I have an individual ARP entry for all the loopback 34.3, 34.4 as well. So ARP. Can you see the one bad part? They are the same subnet for individual IP address. I'm maintaining the separate ARP entry. Don't you think that it's going to consume the high process, high memory utilization, and high CPU?
Exactly.
It's a bad thing, man. If you're going to configure the static route this way, the next hop one, it's amazing. For this one, what happened? You will only have a one ARP table. Let's do that. Let me do one thing. Let's go to the router number 3 right now. And router number 3, what I can do that? I'm going to configure the node router static and commit this guy. I'm going to configure the next hop behavior. Commit this guy. Now I'm going to ping from here. Ping to whom? 101. Ping to whom? 12.1. Ping to whom? 12.2. How many ARP entry will we have for me? Just one, man. As R3 has a multiple one. Hold on. It's an older one. Let me delete this ARP entry. Interface 0/0/0/0/0. Shut down. No shut. Sorry, shut down. Commit this guy. No shut. No shut. Come with this guy. Show ARP. All good. Now think from here 10, 1, 12, 2. And yeah. Can you see? Did I generate the ARP request for the 12.1? No. Ping the 12.2 as well. Show ARP. No entry. Ping the 1.1 as well. Show ARP. No entry. That's a beautiful part we have, right? For the next hop command. For the next hop, you can see that I don't need to maintain the extra entries, but for the exit interface, in a one broadcast, let's say example 192.168.1.0/24 subnet. This subnet has a 254 IP address. It means that for the 254 IP address, I need to have a 254 ARP entries. And these entries are valid for the 4 hours. So 4 hours, this entry will consume the some amount of extra memories. Maybe the 50 bytes, roughly 30 to 50 bytes is not a big amount. Think about it. Imagine it. If you have a 10,000 IP address on the router side, like not IP address, or if you're pinging the 10,000 IP address from the router number 1, you will have a 10,000 ARP entry on the router 1. This is the dangerous command, man.
But sorry, trainer, from this show app now you are showing us on arrow 1, right?
Mm-hmm.
So, but we are seeing different MAC address. These are different.
They are same MAC address. Can you see that? Same MAC address. These are the MAC address of the router number 2, this interface. You can copy it. I'll show you that. Show interface /0.
Okay.
Right.
Okay. So
Same MAC address is there.
So router number 1 will have the app entry would be the number of routes you have, So
Whatever the route you have, they will maintain the ARP entry for the individual route. That's why I mentioned this point over here. You see that? For every single destination, I will generate the ARP request. But in this case, I'm generating the ARP request only for the next hop IP address. So if you already have a ARP, then you will not generate it, right?
Exactly.
That's a bad part of this command. This is the dangerous command. Nobody's are using it. Now the question is that why we have introduced this command then?
Exactly.
Exactly. Anyone has encountered this older guys? This picture. Anyone knows this link?
Yeah, that's a point-to-point link, right?
Serial link.
Serial link, exactly.
This configuration was for the serial link because on the serial link, we don't have a concept of the MAC address.
Oh, I see.
So it was a longer time, man, 90s time. People were using it, but nowadays Ethernet technology has a MAC address. We don't use it.
Yes.
All good. So tomorrow we'll have a plan for this one, right? And we'll discuss the more about the static pros and cons and the design level perspective. And then I'll give you the proxy app concept more about this one. And we'll go in. Meantime, what you can do that, I'll suggest you to please read this document. It will give you the quick overview, right? Why you should not enable the proxy app. If you go to the down, and I'll show you that. These are the major disadvantage. Increase the amount of the ARP traffic on the segment. Larger ARP table, security concern will be there. Anyone can perform the spoofing attack. DDoS attack comes in the picture. So never enable the proxy. I'll paste this link on the chat. I've gone through this one.
Yeah, thank you so much.
Okay, let me change this to the all. Yeah, I'll paste this in information chat. Go through this one. Anyone has a doubts, guys? It's clear to everybody?
No, it's clear.
Thank you. So I'll save this notepad. I will share this notepad tomorrow. Once we have done with the static route. So studying static route speed. All good?
All good. All good. All good.
Okay, see you. So I'll see you guys. Anybody has a question, you can ping me. Otherwise, I'll see you tomorrow, guys, at the same time. Okay.
Have a good day.
Have a good day, guys.
Thank you, sir.
Thanks, buddy. Thanks, everyone. Will you please post this link in the WhatsApp group? I'll do that, Oscar. Don't worry. I'll post that. Thanks, buddy. Bye-bye.